So today I am going to discuss the very important concept with you. So in one of the video I have clearly explained that for the molecules containing up to 14 electrons we have to follow one order, and for the molecules containing more than 14 electrons we have to follow one order in order to fill the electrons in the molecular orbitals. So coming to the gist of that particular video is up to 14 electrons, the order is sigma 1s is less than sigma star 1s is less than sigma 2s is less than sigma star 2s is less than pi 2px similar to pi 2py less than sigma 2pz less than pi star 2px similar to pi star 2py less than sigma star 2pz. Now coming to the molecules containing more than 14 electrons, that is, in order to fill the electrons in the molecular orbitals, for the molecules containing more than 14 electrons, only the change is the sigma 2pz will move ahead of pi 2px and pi 2py. So that we are going to discuss now. So this is a general molecular orbital energy diagram for any of the molecules, general molecular energy and diagram. So let us consider that X2 is the molecule. And since the X2 is a molecule, so definitely the atoms present in this molecule are X atoms, right? X atoms. And this is one of the atom of this X2 molecule, and this is another X atom of this X2 molecule. Now let us say that 1s atomic orbital of the X atom is combining with another 1s atomic orbital. Now according to one of the postulate of the molecular orbital theory, it is amply clear that the number of molecular orbitals combined is equal to number of atomic orbitals combined. That is, number of molecular orbitals formed is equal to number of atomic orbitals combined. Now as 1s orbital of this X atom is combining with another 1x atom of this atom, results in the formation of the two molecular orbitals. Out of the two molecular orbitals, the one will be associated with the lowest energy level, which is bonding molecular orbital, and the other one will be associated with highest energy level, which is a sigma star 1s. And why the bonding molecular orbital is associated with lower energy and anti-bonding molecular orbital is associated with more energy, I have very clearly explained in the basics in molecular orbital theory. That is why bonding molecular orbital is stable than bonding molecular anti-bonding molecular orbital. That is, as the stability is inversely proportional to energy, we can say that why bonding molecular orbital is more energetic when compared to anti-bonding molecular orbital, right? So now please do watch that video. That is the reason before I explain this particular topic, I have uploaded that video, because in that video you will get the clear cut picture about why bonding molecular orbital is stable than anti-bonding molecular orbital. If you are not watching that video, and if you watch this particular video without watching that, definitely there will be a lot of ambiguity in this video. Please do watch that video, otherwise you will not get the clear cut information in this particular video, right? So 1s atomic orbital is combining with 1s atomic orbital of another atom, resulting in the formation of the two molecular orbitals, out of which one is associated with lowest energy, which is sigma 1s, and other one is associated with more energy, with which is sigma star 1s, right? Now the 2s atomic orbital of X atom combined with the 2s atomic orbital of another X atom results in the formation of the two molecular orbitals, out of which one is sigma 2s, which is the bonding molecular orbital, and the other one is sigma star 2s, which is anti-bonding molecular orbital. Right. Now coming to the p orbitals. 3 p orbitals of the X atom combined with 3 p orbital of this X atom results in the formation of 6 molecular orbitals. 6 molecular orbitals. Why 6 molecular orbitals? Already it is very clear that number of molecular orbitals formed is equal to number of atomic orbitals combined. Since 3 atomic orbitals of this X atom are combining with the 3 atomic orbital of this atom, definitely 6 molecular orbitals are going to be formed. Out of the 6 molecular orbital, which molecular orbital is formed first? The 3 p atomic orbitals, p atomic orbitals are perpendicular to each other, and they will approach in this manner. When they are approaching and when they are perpendicular to each other, initially sigma bond is going to be resulted, followed by pi bond, followed by pi bond. And as the internucleus axis is z-axis, by default internucleus axis is the z-axis, so that's the reason sigma 2pz, followed by pi, followed by pi. And these pi atomic orbitals are equally perpendicular to each other. Since these pi atomic orbitals are equally perpendicular to each other, the energy associated with these 2 pi atomic orbitals is one and same. That is, they are degenerate orbitals. That is the reason this is pi 2px and this is pi 2py. Right. Pi 2px, pi 2py. Pi 2px, pi 2py. Now, sigma 2pz. Sigma 2pz is occupying the lowest energy level. That is, occupying the lowest energy level means as the energy is inversely proportional to the stability, we can say that sigma 2pz is more stable than pi 2px and pi 2py. Right. Now it is more stable than pi 2px and pi 2py with the quotient of plus 2 psi a psi b. Now what is exactly the plus 2 psi a psi b quotient? I already have clearly explained in the video in which I have clearly explained about why bonding molecular orbital is more stable than anti-bonding molecular orbital. That is the reason definitely you have to watch that video before watching this video. Right. Now sigma 2pz is occupying the lowest energy level, means sigma 2pz, the molecular orbital, is more stable than pi 2px and pi 2py. Now we are saying that sigma 2pz is more stable than pi 2px and pi 2py. Why it is stable? It is stable with the quotient of plus 2 psi a psi b. Plus 2 psi a psi b, it is stable. Now with the same quotient, it will be least stable. That is, with the quotient of minus 2 psi a psi b, with the quotient of minus 2a psi b psi a psi b, it will occupy the highest energy level. So already I have clearly explained in the previous video. Right. Now coming to the pi 2px and pi 2py. Right. Pi 2py. Now the next will be pi star 2px and pi star 2py. Okay, so this is the general order. This is the general order for filling the electrons in the molecules. This is the general molecular orbital energy diagram. That is, sigma, first the electrons are filled in sigma 1s, next the electrons are filled in sigma star 1s, next the electrons are filled in sigma 2s, next the electrons will be filled in sigma star 2s, next sigma 2pz, next pi 2px and pi 2py, because both are equally perpendicular, so the energy associated with these two will be one and same. These are degenerated. Now what is happening? The sigma 2pz is more stable than pi 2px and pi 2py with the quotient of plus 2 psi a psi b. Now since it is more stable with the quotient of plus 2 psi a psi b, its anti-bonding molecular orbital will be least stable with the quotient of minus 2 psi a psi b. That is, least stable means high energetic. So that is the reason sigma star 2pz occupies the highest energy level. So this is the general order. And this general order can be observed from oxygen molecule. That is, the molecules containing more than 14 electrons in it. In order to fill the electrons in the molecules containing more than 14 electrons, we have to follow this order. Why? This can be explained on the basis of sp mixing. This can be explained on the basis of sp mixing. Right? sp mixing. What exactly the sp mixing is? Now in this case, sp mixing is not possible, as 1s is mixing with 1s, 2s is mixing with 2s, 2p is mixing with 2p. There is no sp mixing. Now from oxygen, sp mixing is not possible, but up to nitrogen, sp mixing is possible. What do you mean by sp mixing? Now for all this, 1s2 2s2 is common, 1s2 2s2 is common. For the boron, 1s2 2s2 2p1. For the carbon, 1s2 2s2 2p2. For the nitrogen, 1s2 2s2 2p3. For the oxygen, 1s2 2s2 2p4. For the fluorine, 1s2 2s2 2p5. Now as we are moving ahead, what is happening? S is constant. S is constant, but P is increasing. P is increasing. P character is increasing. Now P character is increasing means what? The energy gap between S and P is increasing. The energy gap between S and P is increasing. As the energy gap is increasing, as we are moving from left to right, practically it has been observed that up to nitrogen molecule, sp mixing is possible because the sp mixing is possible because the energy gap between S and P is less up to nitrogen molecule. But as we are moving ahead from nitrogen molecule, the gap between S and P increase. When the gap increases, sp mixing is not possible. When the sp mixing is not possible, then it follows this order. So that is the reason from oxygen molecule this order is followed. This order is followed. Right? So sigma 2pz will be first, followed by pi 2px and pi 2py. But in the case of the molecules in which sp mixing is possible, that is up to nitrogen, the sigma 2pz molecular orbital will move ahead of pi 2px and pi 2py. So what is that reason we are going to discuss now. We are going to discuss now. Right. Now when we are discussing about the sp mixing, when we are discussing about the sp mixing, we have to not discuss the sp mixing of 1s and 2p orbital, because the energy gap between 1s and 2p is more. So sp mixing is not possible between 1s and 2p, right? And the energy gap between 2s and 2p is less, hence sp mixing is possible between 2s and 2p atomic orbitals. So we should not talk in terms of 1s and 2p, so we can violate this. Now what is happening? So let us say that this is the energy level of 2s and 2s. So before going to discuss the sp mixing, so do remember that sp mixing is only possible in the case of symmetrical atomic orbitals. What do you mean by symmetrical atomic orbitals? Symmetrical atomic orbitals means sigma will mix with sigma atomic orbital, pi will mix with pi, pi will mix with pi, bonding mix with bonding, anti-bonding mix with anti-bonding, because their geometry will match whenever they are symmetric in nature. So bonding with bonding, anti-bonding with anti-bonding, sigma with sigma, pi with pi. Only this mixing is possible. Sigma with pi, pi with sigma, bonding with anti-bonding or anti-bonding with bonding, this mixing is not possible. Now according to that particular stuff which I have explained to you, however, we can violate this 1s atomic orbital or molecular orbitals. Now we have to consider only the 2s and 2p atomic orbitals, because they are closer enough to mix up. Now first let us discuss anti-bonding molecular orbitals. Already I said that sigma overlaps or mixes with the sigma only, and anti-bonding overlaps with the or mixes with anti-bonding only, anti-bonding. So this overlapping is possible. This overlapping is possible because sigma 2s, sigma 2pz, sigma symmetrical, sigma star anti-bonding, sigma star anti-bonding, symmetrical. So mixing is possible. Now coming to this one, and this particular thing, that is, this mixing is possible. Sigma 2s mixes with sigma 2pz, because sigma and both are bonding molecular orbitals. This mixing is possible. Now let us discuss first about anti-bonding molecular orbitals, sigma star 2s and sigma star 2pz. Now let us say that this sigma star 2s is psi a, sigma star 2s is psi a, sigma star 2pz is psi b, right? Now out of these two, 2s and 2p, which is closer to the nucleus? 2s is closer to the nucleus. Since 2s is closer to the nucleus, the attraction towards nucleus is more, and as the attraction is directly proportional to stability of psi a is more. As the stability is more, energy will reduce. Now what happens is this won't be like this. Its energy is reduced, so it will come over here. Energy is reduced, but it will not enter into the bonding molecular orbital. Do remember that, because it is anti-bonding only. Even though its energy is reduced with psi a plus psi b, it will not have more, that is, it will not be stable as sigma 2s, because always the bonding molecular orbital is more stable than anti-bonding molecular orbital. Now one hybrid orbital has been formed. Now what is happening to psi a? Its energy has been decreased. So out of the two wave functions, if one wave function energy is decreasing, what will happen to the energy of other wave function? Other wave function is psi b. So the energy of psi b will increase. So energy of psi b will increase, resulting in the formation of the hybrid orbital, another hybrid orbital, right? So another hybrid orbital, the energy will increase. The energy of what? Energy of sigma star 2pz has been increased. Sigma star 2pz has been increased. Okay, now is there any difference in the energy level? Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s, sigma 2pz, pi 2px, pi 2py, pi star 2px, pi star 2py, sigma star 2pz, right? Energy level has been increased, but the energy order has not been changed. The energy order is one and same. Only energy level has been increased. Psi a energy has been reduced, psi b energy has been increased. That's it. There is a change in the energy level, but energy order has not been changed. When the energy level is same, that is, energy level is same, means okay, energy level, we cannot reveal much from the energy level. We can reveal only from energy order, but there is no change in the energy order. When there is no change in the energy order, why I am explaining this sp mixing? So we have combined only anti-bonding, symmetric anti-bonding molecular orbitals. We have not combined symmetric bonding molecular orbitals yet. So what are the symmetric bonding molecular orbitals are left? Sigma 2s and sigma 2pz are left. Now let us say that sigma 2s is psi a and sigma 2pz is psi b. Now which is closer to the nucleus? Sigma 2s is closer to the nucleus. Since it is closer to the nucleus, its attraction towards the nucleus is more, and as attraction is directly proportional to stability, its energy is reduced, because stability is inversely proportional to energy. Now its stability is reduced. Its stability is reduced, that is, energy will decrease. Energy will decrease. Energy will decrease. Energy will decrease. This is what? Sigma 2s. Sigma 2s. Now is there any change in the energy order? Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. No change. But when psi a energy is decreasing, what is the psi b? Sigma 2pz is the psi b. So definitely when psi a energy is decreasing with psi a plus psi b, so definitely the energy of psi b increases with the quotient of psi a minus psi b. So that is the reason sigma 2pz will move ahead of pi 2px and pi 2py. Pi 2px and pi 2py. So what is this? This is sigma 2pz. Now is there any change in the energy order? There is a change in the energy level. At the same time there is a change in the energy order. Sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. From up to here it is quite common even for the molecules without sp mixing. But what is happening after sigma star 2s? which is occupying the lowest energy level, pi 2 px, next similar to pi 2 py, because both are equally perpendicular, and sigma 2pz is moving ahead of this pi 2 px and pi 2 py, and the remaining are 1 and same, right? So my dear students, up to nitrogen molecule, sp mixing is possible. When sp mixing is possible, this is the molecular orbital energy diagram, because what is happening in this, the energy of sigma 2pz is increasing because its related psi a, which is sigma 2s, is decreasing its energy with the coefficient of psi a psi b. When it's decreasing with the coefficient of psi a psi b, its energy will increase with the coefficient of psi a minus psi b. That is the reason it will move ahead of pi 2 px and pi 2 py. So that is the reason why up to the nitrogen, since the sp mixing is possible, we have to follow this order, that is sigma 1s is less than sigma star 1s is less than sigma 2s is less than sigma star 2s is less than pi 2 px similar to pi 2 py less than sigma 2pz less than pi star 2px similar to pi star 2py less than sigma star 2pz. Right? And while in the case of the oxygen molecule, this sp mixing is not possible, so we have to follow the regular pattern of molecular orbital energy diagram, that is general order of molecular orbital energy diagram, which I have clearly explained in this video at the beginning. Right? I hope you understood this. So because of the sp mixing only there are two order of filling the electrons in the molecules. One is up to 14 electrons and the second one is more than 14 electrons. But don't think that it is a myth, okay? It is a fact. So please don't memorize anything. There is a concept behind it. There is a concept behind each and every topic. So please try to know the concept, but don't buttify or mug up. So thank you for watching the video. Please comment on this video.